So as we do this exercise 3, this first real practice at getting some unit testing in place, I'm just going to start off with a class library application. I'm going to call it Willie Game, all right, and I'm just store it here. So it's just a straight C# class library, nothing special about it whatsoever. Take a moment, get this up. All right, so here's our actual exercise, right? So it's unit testing exercise 1, which is actually homework exercise 3, but that's okay. The idea is we're going to be working on a game development project, right? I shouldn't make assumptions because not everyone plays with the same sort of deck of cards that we typically do around here. But, you know, a typical deck of cards in this part of the world is made up of 52 cards. There's 4 suits. You have ace, and then numeric values 2 through 10. Then you have the face cards, jack, queen, king, right? So this is a very simple card game. Everyone gets 2 cards. Suit does not matter, plays no role in the game. The value of the player's hand is the total of the face value of the 2 cards, except, okay, face cards are all worth 10. Aces are always worth 1, right? So we're going to create a class file that will hold a Willie hand object, okay, the 2 cards that make up the Willie hand, and have some properties. We'll use the constructor to actually kind of deal the cards out, card 1 and card 2. And then we'll have, obviously, we need to be able to access the properties. What are the values? Like what actually is card 1 and card 2. But then the Willie value is that calculation, depending if it's a face card, et cetera, right? Okay, so we have the starter class right over here. Fortunately, if you try and copy out of here, it doesn't come out very nicely formatted in Visual Studio. So that's why I gave you a separate little text file you can copy the class out of instead. But the idea is we're going to follow some use cases, right? And for a given value for card 1 and card 2, we expect a certain Willie value, right? So this is to test if our class is doing the proper calculations on the Willie value, and away we go. So that's the general scenario of what we're going to do. So I'll just bring the project over here. So here it is, my Willie game. So I can rename this to Willie Hand for our Willie Hand class. Yes, please. And I'm going to make it a partial class. We've talked about, and you've worked with partial classes before, but my motivation for doing so will come clear later on as we're going to expand the class in a separate class file eventually, right? Okay, so I'm going to get the code here from the posted original version, the starter version of the class, and just throw that in, right? So we have some private variables here, our integer values. Remember, suit doesn't matter, so it's just a numeric value of the card, right? Card 1 and card 2. We pass them in the constructor, and then we can access the different properties as we go along. Now, one thing I would encourage, getting in the habit of, even right now, it really helps with our IntelliSense and everything else, is if we get in the habit of actually adding some summary properties. So even to the class itself, we've done summary properties as the 3 slashes, right? And then I can just quickly then add a little comment here that will appear in IntelliSense to tell me a bit about the object and each of its properties and so on here. So on the constructor, I might throw in something like this. Say, pass the integer values of the cards as you construct the hand. Of course, it sets it up with the comments for the parameters, right? The first card, the second card, and so on and so forth, okay? And, you know, if I was going to carry on with that approach, I'd probably end up having these very simple comments, but it doesn't hurt to have them for each of the other parts here, right? So let me just, it's easier for me to do this all at once, so there we go. The Willie value of the hand, the actual value of card 1 and 2, the first card, the second card, because of course, you know, a jack will come in as 11, a queen will be 12, and a king would be 13, right? So that way we can actually find out the actual values of those cards as we retrieve them from the Willie hand itself. Of course, the Willie value is what we actually compare then to see who wins, okay, who has the highest Willie value of their hand. Okay, very, very simple start to a very, very simple card game. By the way, if you try to research this card game, good luck, because I just made it up out of my silly head. But I find it works well as a nice simple scenario to follow along for doing unit testing. So as we said, now we're ready to start testing and seeing, are we getting the correct results, okay, for given use cases. If I have a 9 and a jack, do I get 19, et cetera, right? So we did it once before in our first number fun example, but to add unit testing here, what I could simply do is I could right click and I could say create unit test. Now it is true, let me pause in my demo here for a second, you can actually incorporate tests right into the project itself. That's not considered the best idea. Best practice really calls for a completely separate test project, usually as part of the solution itself. And that's what it's going to do for us here by default. Now, I can mess around and change some of these settings, but I'm going to leave all the defaults as it is. Notice it defaults for a given test framework. We mentioned in our discussion that there's X unit, N unit, there's different options out there. This is Microsoft Test, okay, version 2, and that's what we're actually going to use, right? So I'll just click OK, and it's going to do all this nice work for me, creating a totally separate test project. Just took the name of my class library, added the word test at the end. Notice in the dependencies, it actually depends as the dependency to our actual class library, so I can access all the public and so on classes and methods and everything else in my actual Willy game right from my test project itself. It even scaffolded my first. It saw I have a WillyHand class, so it created our WillyHand test class here, decorated it with test class as we discuss these different annotations that are available as part of the test framework. And then our first test here is marked as a test method. And by default, of course, good practice, it has assert fail. Remember, we saw that in our quick little demo we did introducing our first number fun example. It's always good to have the assert fail there until you've double checked that everything in the test, all your arrange, your act, and assert is all ready to go. And only then would you change it and get rid of assert fail. It's like it's a fail safe, isn't it? Okay, so if I'm going to follow along in the same basic thread of discussion, what I'll do is I'm going to add summary properties here to identify nice in good readable comments what this actual use case is going to be. So this is my first test based on the use case A1. I'm going to pass a 9 and a jack. I'm going to expect the Willy value of 19, right? Now, of course, I have to have unique names or signatures at the very least, so I might get in the habit of putting something here like test case A1 or A1, something like that, right? Just to tell each one apart. Okay, so that's the use cases A1. All right. Now, the next thing we'll add, of course, is our good 3-step process. Okay, we will arrange, then we will act, and finally assert. The good overall approach to unit testing, right? I'll emphasize again, it's so important to keep our unit tests nice and simple, right? So that there isn't a lot involved in them, so we don't have to worry about making tests to make sure the test is testable itself, right? Nice and simple. And, I could just take some shortcuts and just say, well, I'm just going to create a WillyHand, pass in the values described here, the 9 and the jack, but it's maybe overkill in some people's mind, but I like to do it. I'm going to actually put in the actual integer values here for card 1 and card 2, okay, being 9 and 11, right? And then I will, because it's not a static, I have to instantiate or new up my actual WillyHand. So that'll be the next thing I'll do in the arrange, okay? And as we discussed the other day, I'm going to name the object target because it's my target of my test, right? So it's a WillyHand object, named target, and I new up a WillyHand passing in the values that I established up here as part of the steps for arranging. Now, also considered as part of the arrangement is to specify, okay, that's good so far. what is the expected result of the test. The expected result should be 19. That's right in the use case itself. Okay, given a 9 and a jack, I should get 19 because we know jack is a face card, so that should be evaluated as 10. 10 plus 9 should be 19. Whew, all right, we're on a roll. Okay, now what is the act itself? Well, the way we've set up this particular class is we simply access the Willy property, right? So if I go to my target, go .willy, that gives me my actual value. Then I'm finally ready to get away from assert fail and maybe go with assert. We've talked about all the different variations here. I simply need an R equal. I'm not worried about types here because we're just talking simple integers, right? Assert R equal. And you see that we have expected and actual. So it is no coincidence that I actually chose those names for my variables up here, right? Expected and actual. So that should just make sure they're equal. Now, if I leave assert fail there, I'm definitely going to get a fail, right? Let me just save everything. And I'm just going to run tests. And we should definitely get a fail because that's what I have is assert fail. There we go. Okay. Oh, look at that. Notice this. Assert R equal failed. So it even failed on our assert R equal before it got to assert fail, right? Ah, interesting, eh? Well, let's just check that out, okay? Well, maybe I made a mistake. Maybe this is the problem. I'm going to take that out, and I'll just run failed tests. It isn't the problem, but I'm just saying let's approach this as thoroughly as possible. Okay, no, that wasn't the issue. It wasn't because I had assert fail. It failed before I got there. That's something maybe to note for the future. I mentioned in our earlier discussion that for the most part, we usually follow as a rule of thumb that you should have a single assert in any unit test, right? Nice and clean and logical approach. It's a rule of thumb that I often break. If you have 2 or 3 things to confirm or to test based on the exact same arrangement, to me it's a very small sin to say, well, tell you what, I'll have 3 different asserts here, right, for the same arrange and act, right, and I can assert 3 things at once. Because if any one fails, the test fails. And that kind of shows it here. See, the first time an assert failed, it stops at that point, right? So if you have 3 different asserts, right, testing 3 different things in a given unit test, I'm just talking about something that will come up down the road, it'll stop at the first one that fails. So there's no way you'll get if you pass, you only ever pass because all the tests pass, all the asserts pass. But anyway, here we go. So our assert failed. Expected 19, actual 10. Okay. Wow. Did the person who wrote up our use cases here, did they make a mistake? No, it looks like this use case is valid here. So what is going wrong? Well, remember we looked at the fact that we can debug, right? So I could come in here, I could set a breakpoint, okay? Or I could even set a breakpoint in here. I could do both if I wanted to. And then I can come in and say debug. All right, so it stopped in the test class first, right? This silly little bar is in my way. That's not fun. Okay. All right, so I'll just step over. All right. And now I'm going to step into, so we'll go into the actual class, but you see, I can see I've got a 9 and a jack, right? So I've confirmed that, yes, I've definitely doing the right thing. So let's go in here, right? I've got the 9 and the jack, the 9 and 11. Oh, wow. Step out of there. Step over, step over, step over. Okay, so now we're back here, right? I'll get the test is actually here. We'll access the Willy. So I'll go in. Oh, it went over it. I wanted to go in there. Oh, I should have set a breakpoint in here. That's my problem. Okay, well, that's all right. I'll just stop for a second, and we'll do that again. Tell you what, I will clear this breakpoint. I really didn't need to see that again. Okay, I just have the one, I'll just leave the one breakpoint right here in the actual Willy. Okay? All right, let's just do this one more time. Debug. So now I've come to the point where we're actually evaluating the Willy. So that's where I'm at in my debugging here. So I'll just step down here. Card 1, right? Card 1 for sure is 9. Is it greater than 10? Nope. So, we'll just carry on here. So card Willy will be card 1. Good. Yeah, so far our Willy is a value of 9. So now we check card 2, okay, which is 11. Greater than 10? Yes, indeed. Uh-oh. You see it? I see it. Instead of adding the value of card 2 to card 1, look at that. We replaced, that was 9, and we replaced it with 10. There's our problem, okay? We have found a bug by going through debug mode. All right, so I might as well stop here because I clearly need to fix that issue. I need to do a plus equals so that I'm adding the value of the second card to the first one. Now, I could go on, and if I do a subsequent use case later on, I'll notice that I have the same issue here. But you know what? I'm just going to fix it now, right? So we've identified that there was a logical error in our original class, that we were replacing the value of Willy with the second card, not adding it to the value from the first card. Okay, so I'm confident enough that I'm just going to run failed tests. Now notice that even though I had a breakpoint here, we never stopped on the breakpoint because I didn't ask for debug mode. So I might as well clear that now. So now we passed. Yay! Round of applause. Yahoo! We passed our test. And that is basically pretty much as simple as that, right? Let's just do one more. I'm going to throw in another use case. So if I come back here, I could copy this, right, and just change values to get the next use case in place. So copy. Okay, so of course it's going to complain until I change the name of that. So this will be use case A2, which according to the instructions, let me just get it here. So we have an ace and a queen. We expect a value of 11, right? So that's going to be our use case. Now, after our discussion, I really should have an assert fail in here until I finish making the changes, but I'm going to do it quickly, so I think it's going to be okay. So an ace always is worth 1. A queen is worth 12, right? So then we expect a value of 11. And I could just come down here. I could say not run tests. And there we go. So notice it didn't rerun A1, but it ran A2, right? And they're both passing. Okay. All right. So that's the general idea. Now, I could get the others in place, maybe just so I have them in the solution before I post this. I'm just going to copy and paste them out of my little file here. But, it's really pretty much all straightforward. Okay. Well, actually, what I'm going to do is I'm going to run all tests. So I have case A1 right through A6, and everything passed. So looks according to my use cases, I'm good everywhere. I should be fine. One other thing I might do, just because I don't want to necessarily, although there's options allowing you to do that, to create a separate test class. I'm just testing the Willyhan class here in this one test class. But, I might want to actually define a region. It's not necessary, but, it's not a bad idea when you start getting lots of tests to organize them a little bit, right? So maybe right here I will define a region. So it's exercise 1, part A. So these are all the tests that are part of part A. And then, of course, I'll just end the region after the sixth one, right? So that'll just be end region. There. Okay. And of course, that does mean I can just nicely collapse the region, and away we go. All right. Well, we're doing just fine. Let's come back to the instructions. Okay, so we've managed to complete all of the 6 tests that were assigned to us to create for part A, right, where we have the different combinations. You notice there was some logic. The person put this together, checking like 2 face cards, checking a 10 and a face card, or a face card, and, different combinations of ways that you would have, like kind of we did our biggest first, biggest second, things like that with our simple num_fun class. Now in the B part, okay, it's a variation of the game, right? Allows the player to pass on the second card. Says, no, I think I'm going to win, right? Just standing on 1 card. If they do, right, then there's some bonus for them. The points they earn or something like that are doubled, right? If they actually can win, if they have the best hand, okay, the Willy value of their hand is the best one, and they only have 1 card as opposed to 2, right? So in order to handle that situation, we have some new use cases, okay? We have a few of them here where the second card is null. Now you might say, well, what about passing on the first card and then, no, yeah, that's just not reality, okay? You'll always get 1 card and then you might decide to pass on the second card, right? So here are use cases for part B. So I might as well just start a new region, okay, in my test class. A new region, end region, and this will be for part B, right? Okay, so our first use case, I could copy an earlier one, but I'm just going to save a little bit of time here because it's copying and pasting is, you don't really learn much from watching me do that, right? Okay, so this is B7, a jack and a null. Okay. Oh, sorry, I shouldn't have just copied. Okay. So the idea is we want to do a jack, a null, an expected value of 10, right? Because of course the jack is worth 10, the null should be worth nothing, and away you go. So here's the problem I'm going to quickly get into if I was doing this from scratch, right? My card 1 would be 11 for the jack. Card 2 would be null. Now, right away, of course, I'm going to get an error. Can't convert null to int because it's non-nullable, right? So I could maybe interpret this a given way, maybe talk to the person who's the developer, lead developer. Should we just pass 0 for nulls? No, it really should be a null because that's how the use cases were set up. So I can fix that by making it a nullable int. There we go. Problem solved, right? Oh, here's a little problem then. When I new up my Willy hand object, my target object, it is defined to receive integer values, okay? So I actually would have to make a change in the class for me to be allowed to pass a null value, okay? 0 would have handled that, but no, we're going to stick with null. So now I have to go and actually come over here to my Willy hand and in the constructor say, you know what? I'm going to allow a nullable int for the second card. There we go. Problem solved. Well, sort of. Except that now it's just passed on for the run. Now our card 2 here, okay? Well, I could make it a nullable int up here as well, or I could say enough is enough. I've made enough concessions to this required change so far. So all I'm going to do is I'm going to take this nullable int and do what we normally do. Get value or default, right? And that will take the nullable int, okay, convert it to a regular integer, okay, and of course give the default value, which is 0, right? There we go. And for card 2. And if my logic is good everywhere else, I think that should still work. That should be valid now. But let's just do a test to see if we actually get our expected value by running the test itself, right? So I'll bring back my test runner here. And you know what? I've made a change to the actual Willy hand class. So at a case like this, I'm going to run all the tests, right? Because I want to rerun all my earlier tests to make sure the change I made, I didn't break anything, right? There we go. We build, we run all the tests, and look at, we passed. So that was successful in getting our new case handled, our special case where we passed null. Now, of course, right, I've got 3 more here, different variations. So that's a face card, a 10, a 9, and an ace. Those are all valid things I think it's worthwhile testing, and I should get these expected results, and away we go. All right, so I'm not going to make you watch me do that from scratch. Let me just get the code in place. To complete the tests here. Okay. So within the same region, I have my other use cases here. All right. So again, I have a 10 and a null, so 10 and null, and then I'm expecting 10. I have my 9 and null, expecting 9. My ace and null, of course, expecting 1, because aces are always worth 1 in this particular card game. So that's good. And once more, I'm going to run all tests in view. I could just run the not run tests, but I don't have that many. Believe me, when you start having 1,000, 1,500 unit tests, you will learn to be a little bit more choosy about which tests you choose to run every time. But of course, every once in a while, and we discussed this point the other day, it is important essentially to make sure that none of the changes you've made have propagated to cause problems throughout the system. So, is unit testing 100% foolproof? No. You have to come up with good, reasonable use cases, right? And then make sure that you're testing likely scenarios, oddball situations that could cause a problem, and so on and so forth. So it might seem like it's the most boring kind of code you could ever do, but at the same time, it's so essential these days as everything gets more and more complex and complicated as time goes on. All right, so I'll just come back here. Okay. Yeah. All right. I just encourage you to use comments and so on there. So that basically finished our unit testing exercise 1. Now, as I said, I just posted the next exercise where we'll take this class and we'll build on it. Okay, we're going to add more and more functionality to our overall game because, you think about it. Well, maybe I'll just mention it now. What really comes next is, all right, that's good. We have this willy hand. But there's more complexity we can add to this. What if you want to compare 2 willy hands? Well, we need some sort of a object that'll do the comparison, right? And then, of course, determine which is the willy winner, which hand wins, right? And then, of course, there's different situations that can come up there as well. What if there's a tie? Well, how do we handle that? So anyway, that's the kind of thing we get into in the next part. But that just kind of finishes walking through the first part of the homework exercise. Hope you find that a little bit valuable, helping you make sure you're ready for further work in unit testing. And of course, eventually, after the break now, we'll actually have our first test, well, our one and only test on unit testing. All right. Any questions before I stop the recording? Okay.